Happy morning, and I want to welcome you to the meeting Part L with core insulation and Unitherm heating systems. So this morning we'll be looking at the benefits of building with core insulation and Unitherm heating systems to meet Part L and Part F 2019. Our first speaker is Andrew Butler, Technical Manager at Core. He will be discussing the importance of a fabric-first approach, creating a thermal bridge-free design at the wall-to-floor junction with Core's insulated foundation system and floor insulation, looking at the benefits of both, real-life case studies, costings, and more. Following Andrew, we have Liam Jordan, Technical Sales Engineer from Unitherm Heating Systems, who will be discussing Unitherm heating systems, including the LG Therma V or 32 heat pump to meet NZEB regulations, underfloor heating systems, the integration with Core's insulated foundation system, certification, and more. Just to let you guys know, we will be taking questions at the end of both presentations. So without further ado, I will hand you over to our first speaker, Andrew Butler.
Thanks, Lisa. Thanks for the introduction. Welcome along, everybody. Hopefully, we can get something out of today's presentation. It's great to have Liam along today as well from Unitherm. It's a great opportunity for ourselves to get involved with another professional company like Unitherm. They're, I suppose, a very well-known company in the industry in terms of their heating products and underfloor heating. So I think it's a good tie-in today with what we're going to be talking about. So as Lisa mentioned, we're going to be talking about, I suppose, Part L, how we can get there, make life a little bit easy for ourselves, and looking obviously from the fabric end of it from ourselves, and then Liam will take it on from there and how that would work with their systems. So that's my email address there. I have it on my last slide as well if anybody needs it. If you want to send me anything afterwards or during, there's no issues at all. But as Lisa said, there is the Q&A thing there, which we'll cover towards the end. So we'll get going anyway. So just a little bit about ourselves first. So who are Core Insulation? So Core Insulation, we manufacture EPS or expanded polystyrene. So as I talk about EPS during this presentation, it just means expanded polystyrene. We're obviously an Irish company. We're guaranteed Irish. We're in operation over 23 years, various NSAI and BBA certifications for our products. And we were the first company in the country to have all the updated ISO certifications, which was really good. We kind of like to keep ourselves ahead of the posse there and keep the pressure on to keep ourselves up to date on everything, which is good. So a little bit about EPS and expanded polystyrene. So I'm sure there's people on today that are familiar with it, but just in case you don't, we'll just cover a little bit about it. So the picture on the left-hand side here, we have some EPS products. So you see this little kind of granular sugar product, that's our raw material. So what we do is we hit that with heat and we hit it with steam and we expand it. So hence become the expanded polystyrene. The first form that we manufacture is this bead form here. After that, we make it into blocks. So you see the blocks here, that's a cube. And we basically, that's cut out for these huge blocks. So you can see there's two types. There's a gray one, or we call it a silver, and then there's the white, which probably people are more familiar with it. In both of those, you can get various densities depending on what you're going to do. It would decide the density and the compressive strength that you need with the material itself. So that's just, I suppose, a little bit about EPS. Obviously, there's a lot of different materials on the market from an insulation point of view. There's different ways to build. And I suppose as the building regulations change, it becomes more important what we decide from the fabric point of view, and then through to the other parts that we put into our builds. And we were trying to pick something that's going to work, do what it's supposed to do, possibly be more efficient from our costs and our spends on the projects as well. So EPS over the other insulation materials on the market has a lot of benefits. It's a 98% air product, so in terms of its thermal performance, it works very, very well. Price performance ratio, so when you look at an EPS compared to a different material that's on the market, you should be able to use an EPS product on a project and save money as well. That's always a very welcome thing. EPS does not decompose and provides a lifetime application. So in terms of its thermal and its physical performance, day one versus 50 years down the line, 100 years down the line, EPS does not change in its physical state. So if you're specifying it or if you're using it on a project, you know it's going to do what it's supposed to do. Big thing about EPS, it doesn't get affected by water. So you could completely immerse EPS into water. I actually had an inquiry there today about EPS being used as a buoyancy aid on a project. So you can put it into water and it's not going to get affected in its physical or its thermal state. Even pouring concrete straight onto EPS, again, these are a lot of benefits for working with EPS, especially in a country like Ireland when we're dealing with a lot of rain. It's a big benefit to the product. Other materials, you're not supposed to get them wet, or you can't put concrete straight onto them. Even just using it on site, it's very easy to cut. There's no dust off of it. In terms of its environmental credentials, it is recyclable when we cut and shape our blocks in the factory. To the profiles that you see when I go onto the foundation system, we recycle that material in-house. There's no harmful gases used in the manufacturing process or nothing to off-gas when the material is in place. And again, that's another issue with other materials that are out there. Gas is being used to achieve certain thermal conductivities which off-gas over time. And again, as you will see when we get into the foundation system, we can cut and shape. So we can take those big blocks that you saw at the start and we can cut them and shape them as needs be depending on the project. So just a touch on part L of the building regulations, and Liam's going to do a little bit more on this as he gets into his presentation. So obviously everybody knows at this stage the part L, TGD part L was changed. So 1st of November 2019 it came into place. There was a transitional period which is now finished. So from the 1st of November 2020 it's in place. What are the changes? Well, from my point of view, looking at what the products I'm going to talk about today, it's the ground floor. So the backstop U value of the ground floor reduced from 0.21 down to 0.18. If we're using underfloor heating, the backstop requirement for a floor is 0.15. So underfloor heating is still the same. There's a lot of issues and pressures in the construction industry. And again, some of them are justified, some of them maybe not so. There's a lot of talk around the changes in Part L that is having cost implications on our builds. But again, if we choose the right kind of product, there's ways and means that we don't necessarily have to have those cost implications. Some people are saying 7 to 8% more on a build cost as a starting point with the new Part L. But hopefully we can prove that's not the point or the case. So there's a lot of pressures in the industry. We're all trying to get a product that's going to save us some money. We're trying to comply with the building regulations. We're worried about our environmental impact. Building faster, cheaper, labor constraints. There's a lot of things, pressures, whether you're from the design to the contracting or if you're the end user. So there's a lot of pressures out there, and hopefully we can show you how we can save ourselves some hassle on some of those. So the first thing we're going to talk about is our core floor product, so floor insulation product. So as I mentioned, our new backstop U values are 0.18. If we're going with underfloor heating, it's 0.15. So in terms of the EPS, we manufacture different densities, different strengths of material, and depending on its use, we would use that type, the different types of material. So EPS 70, which is a compressive strength of 70 kPa, is available in white and silver. The white has a conductivity of 0.037, the silver has a conductivity of 0.031. And you can just see on the table there how the values change. So the 70 after the EPS 70 always refers to its compressive strength. So equally, any of the others, when I get down to the EPS 300, the 300 refers to its compressive strength, 300 kPa. And you can see how the conductivities change slightly depending on the product. The silver we do up to as far as an EPS 150. After that, it's all white. We do, again, for structural reasons. So just the 3D image on the right hand side here, you just see an EPS 70 silver board being used in a standard enough floor insulation, concrete subfloor, and then we've got the underfloor heating pipes on top of that, and then into a screed layer. So that's a very common, obviously, type of construction. But obviously, as I said, Liam will talk a little bit more about the underfloor heating elements. In terms of compliance and I suppose confidence in our products, from the floor insulation product, we have our NSAI certification, we have design guides, we have typical details, we've all the thermal modeling done. So you can take our details, use our thermal modeling, or obviously we can alter them and change them for your specific project. We have our DOPs and our CE marking. So we've a lot of stuff there to make compliance with the building regulations very, very simple. If you're just on something on standard details, if you're using an ACD and accredited detail, your SI values, your thermal bridging is a default of 0.08. If you're using an enhanced detail, like something we'd have with our floor insulation here, you can get lower SI values, which can help in your BER requirements. Just I suppose a couple of U-value examples. Again, two typical scenarios that we see very, very regularly. So the example on the left-hand side here is a screed, insulation, and then a concrete subfloor. And if we're going to look at using an EPS, so something like our EPS 70 silver, we're using 150 millimeters of that typically in a floor build-up to get to our U-value target of 0.15 if we're using the underfloor heating. That's based on the perimeter area ratio 0.4. If we're looking at concrete straight onto insulation and then onto a stone base, probably around 160 millimeters of our silver EPS will get us to that same U-value requirements. So the great thing is if we're using an EPS, we should be able to save money on the project by using that. Also, we can know that when we specify, when we use the product in terms of its U values and its thermal performance, it's going to do exactly the same thing for the lifespan of the building. So that's not going to change. Even just as I mentioned earlier on, simple using it on site, we can pour concrete straight onto it and there's no issues there. So as you saw at the table a couple of slides ago, we have various densities for EPS. So some of I suppose the more commercial, the heavier loads, we would use the more denser material. So an EPS 70, 99% of the time, perfectly fine for domestic light commercial use and the standard types of loadings that we would see there. When we're getting into, I suppose, the heavier type construction, so we see here there was the top two here. So we've two of the new Joe Duffy showrooms that were built. There was 3 showrooms altogether in North County Dublin, and they use an EPS 300 under the floor there, obviously because there's heavy loads, you have loads transitioning, you have the movement of vehicles and being parked on the floor. Bottom left-hand side here, we've the new combi lift factory in Monaghan. So again, very, very heavy machinery working around industrial floors. They use an EPS 300 in that scenario. And over on the right-hand side here, at the bottom right, we have a development office development in Shelburne Road in Dublin 4. And in this scenario, they basically just used an EPS 70 white. They were using it under the screed layers for the various floors. So they were using it as a little bit of a void filler, but obviously offering a thermal performance as well. So depending on the project, we should be able to come up with a product that should suit that project for you. So moving on to our insulated foundation system. So we're going to look at a different way of building. And this is really where we're going to start to maximize the use of our underfloor heating and the other systems that go into a build. So it's a different way of building. We're getting away from the ideas of strip foundations. We're getting away from the ideas of traditional rafts. What we're doing is we're coming onto a greenfield site. We're stripping our vegetation there as we normally would with any type of build. And when we're doing a stone buildup, a compacted stone buildup, around 200 mil of a T3 stone, small blinding layer of a T3 stone, and then we're basically forming a jigsaw with EPS pieces. And we're fully wrapping the underside of a building. We're approaching it with a fabric first approach here, getting this part right, cutting down on our thermal bridging, eliminating materials, eliminating embodied carbon. We're reducing the amount of materials that we're going to use. So why would you use the insulated foundation system? As I mentioned, it's a different way of building, but it has a lot of advantages. So we're going to be more than NZEB and Part L compliant. We're going to get beyond any requirements of the new building regulations by default by using an insulated foundation system. We're going to reduce our costs. We're going to remove the need for skilled labor. We're going to reduce a lot of materials, because if we compare it to the likes of a strip foundation, we're digging holes in the ground, we're pulling up muck, we're having to deal with that muck. That is very costly. We're putting down concrete strips, we're bringing in a block layer to bring up rising walls. we're taking all that element out. So that's a lot reduced straight away in terms of cost, time, and all obviously materials. Thermal bridging, we're going to wrap the whole underside of the ground floor. We're going to return that material up at the perimeter and reduce our thermal bridging. We're wrapping that ground floor. And if we're using our underfloor heating, it's going to work more efficiently. We're going to have reduced heat loss. We're going to utilize that thermal mass. So we're not going to use an additional screed layer. We're going to put the underfloor heating straight into that concrete slab and make that work for us. So I mentioned that we're going to get beyond Part L requirements. By default, an insulated foundation system, we're going to see usually in the floor somewhere around the 0.1. So we're getting beyond any requirements of our Part L. Again, to give people confidence in the product, we've put a lot of work into the insulated foundation system. We're Ireland's only NSCI agreement certified foundation system. Took several years to get there, but we got there last year, which was fantastic. So we have our NSCI cert. If we're looking to engage with structural engineers, we have a structural design guide to show how it works. We have our installation guide, and we have a training program for installers for the product as well. We have construction details, we have our thermal modeling. So there's a lot of information out there available for construction professionals to help use the product, specify it, and even install it on site. So just again to, I suppose, help people understand how the system works a little bit more. So as I mentioned, we're wrapping a whole underfloor of the underfloor of the building, so the ground floor level. What we're doing is, I mentioned, we come onto our greenfield site, we build up a stone base, and then we're putting down EPS. The EPS comes from the factory, manufactured as per a structural engineer's drawing. It's essentially like a jigsaw. We start at the perimeter, we put out our profile pieces, and we basically fill in with insulation. So if you're looking at this little section through the ground floor here, you'll see under the main part of the floor, which is normally 150 mil of a concrete slab, we have 300 millimeters of EPS insulation here. What we do is we thicken the slab where we need to take our loads. So on the perimeter here, we have a thickening at the perimeter to take, in this case, we're showing a block cavity wall construction. So the inner leaf has the loaded case on it. So we have our first floors, and we have our roof load coming down on that inner leaf, coming onto this thickened ring beam. We have the outer ring beam here, which is taking our outer leaf. And internally then, where we have maybe, if it was semi-detached or a terrace building, if we have party walls or if we have heavily loaded internal walls, again, we just thicken that slab. But at no time is the insulation penetrated. So the floor slab is all encased within the insulation, and it wraps up at the perimeter and lines up with whatever that insulation is going to be in the wall. So no matter what type of build type this wall is going to be, we're getting a full wrap. So we're going to get very, very low U values. We're going to reduce our thermal bridging. Even when we look at the standard strip foundation, we're bringing up rising walls and we're trying to detail around that, trying to reduce that thermal bridging can be a little bit tricky. Even on the internal walls, we've separate strips coming up there. This is all very, very simply catered for when you use something like an insulated foundation system. So as I mentioned, we basically use that concrete slab when we thicken it where we need to carry the structure above. It's obviously used in ground floor construction, and it's an engineered system, so it's specific to the site and specific to the build type that you're going to put on top of whatever that wall construction is. We're going to use two types of EPS. So the EPS 300, where we need to take structural loads, the EPS 100 in the main part of the floor, and obviously we have steel and concrete. So you just see a picture on the right-hand side there. That's a finished ground floor waiting to start the walls. So we use the EPS 300, designed, as I said, as per structural engineers design. I'm using these kind of L or F shape. So this one's kind of like an F shape profile on its side. And then we can use it with any type of construction, really. Timber frame, solid wall with external, cavity wall construction, ICF, SIPs, steel frame, you name it, we've used it. It's a very versatile system. Just to show you the build types, very, very quickly to give you an idea of them. So this is this kind of F-shaped profile, and I've just outlined them in red there. So we've a block cavity wall construction. Very popular again. We've a timber frame with a block outer leaf or a masonry outer leaf. If we're looking at solid wall with external insulation, same thing. We have an L profile this time. ICF, again, this kind of L-shaped profile here. But the great thing is, and the thing that we need to achieve is we have all this level of insulation on the floor, and we're maintaining insulation all the way around here, lining it up with the insulation of the wall, whatever that wall construction is. So we've a full thermal envelope all the way around the building. And as I mentioned, that's just an example of some thermal modeling from a semi-detached project that we were looking at. FRSI values coming in at 0.93, so they have to be over 0.75 for compliance. But the Y values came in very, very low. Again, if we use the ACDs for the standard details, we get a Y value of 0.08. So if you use the right kind of fabric, we can get very, very energy efficient, very, very easily. Just a couple of case studies for you. So some real life facts and figures to give you some information. Obviously, this is just very, very broad overview of the foundation system. It's just to give people an idea, because I suppose there's a bit more to it. So a one-off house, the target, obviously, with the building regulations with our floor was 0.15. They were using underfloor heating. They wanted to go with a certified passive house. And they used our core insulated foundation system in the floors, and they used solid wall with external insulation. And they got very, very low U values. So you can see in the floor, they actually achieved a 0.09. They got a 0.12 in the floor. The contractor, Pat Doran Construction, had never used the insulated foundation system before. So this was his first time using it. Since then, Pat and his crew don't want to use traditional builds anymore. They will only build using an insulated foundation system, and I suppose have become a little bit of a specialist in the field. That they're getting a lot of work on the back of this type of construction as well. So first time using it, great response from the guys on site. When we're looking at, I suppose, again, just the facts and figures to help people understand the system, we would normally say to people, if they're looking at a one-off build, it's probably around cost neutral to use a foundation system versus standard build. Now, you're going to achieve a lower U value. You're going to reduce your thermal bridging, and makes a lot of sense that even if something costs the same, but can give you better performance, surely it's a great idea to adopt that approach. But as can happen, and quite often happens, even in the one-off builds, we asked the builder at the time to do some costings, and they costed up the standard construction. They were coming in at 36,000 odd for standard build. And when they used the insulated foundation system, they actually came in about 4,700 cheaper. Big elements of that was just coming out is the screed, because we're not using a screed, we're using underfloor heating straight into that thermal mass. But the big thing to remember as well is this 36 odd thousand, that was to a not as high performance build. It wasn't as good a U value, wasn't the thermal bridging. So it makes a lot of sense from a cost and performance benefit when you look at an insulated foundation system. On a slightly higher scale, Ireland's biggest certified passive house development a couple of years back by Durkin Residential. Phases 1 and 2 of a development, they went with traditional construction. Phase 3, they went a little bit differently. And again, they used our insulated foundation system, and they used external wall insulation, and they achieved a U value in their floors of 0.1. But the huge benefit, and this ties back to people's, getting bogged down with the ideas that, well, if the changes in the Part L are having cost implications, this isn't necessarily the case, because Durkin were able to build a fully certified passive house and sell it at the exact same cost as phases 1 and 2. So the people in phase 3 were buying a certified passive house for the exact same cost. So they proved it, and other builders have come on board since to say, well, we can build better houses, but it doesn't necessarily cost us anymore. There's a lot of benefits to getting that fabric right. Just comments from the site. I mean, they were saying, like, the reduction in skilled labor, the block layers, because it was a block build, weren't coming in until the ground floor was in. Less concrete and blocks, obviously, at the same time. Reduction in muck away, which can be very, very costly, especially when you're getting into developments. And just a simple thing, it was cleaner site. So very, very positive experience with our foundation system. Again, just as a costing example, when we're comparing traditional strip foundations versus raft foundations versus an insulated foundation system, this was an independent QS did a costing and looked at our foundation system based on this. It's just a standard enough set of 2 houses. They were able to save, they reckon, about €1,500 on the build. Again, getting a better thermally performing ground floor, just at that ground floor level. Versus a strip foundation versus a raft, there was even a more significant saving because there's less steel, there's less detailing in it. It's an easier, simpler build. We're coming off a flat platform here. We're not having to have the stows or the toes at the side and the formwork that goes with the forming the raft. So there's a lot of benefits. We actually supplied a residential development, and they were suggesting their cost savings were actually a bit more than that. But anyway, that was what these people came in at. But again, it's facts and figures to back up kind of what people are saying. Last couple of slides for you. The last thing really is again just about our product and EPDs, environmental product declarations. So this basically states your environmental impact from raw material through production to when the material goes to site. And we're the first board manufacturer in the countries to have this. And a lot of projects is from government led, and even a lot of architects now are specifying projects and products on them that need to have EPDs. So we have this, and basically it means that if you're using different types of energy efficiency software, the BREEAM and the LEED software, you get to your energy ratings a little bit quicker. But again, we have that there. And just on our technical services, please reach out to us. I'll pop up my email address now in a second before I hand you over to Liam. All the things that we can help you with, view value calculations. We've all our thermal modeling done there, typical details, even on-site visits if somebody wanted to see an insulated foundation system. So hopefully you can see, like, if you pick something like an EPS product, how your compliance and your environmental impact will be lessened. You certainly got to build faster and cheaper and possibly save money when we use something like an insulated foundation system. So the products can really stack up for you there. And that's it. And thank you very much. I hope everybody got something out of it. So that's my email address and my details there. And I'm just going to hand you over to Liam now. Thank you.
Hi there, everybody. Thanks a million, Andrew, for that. 2 seconds there and just get this up. So hi everyone, thanks Andrew for that, and thank you for joining us today. My name is Liam Jordan and you're welcome to our online CPD on Meeting Part L 2019. There's my email as well on the bottom. Just if you want to send any queries or if you have any questions, you can email me and I'll get back to you as soon as possible. As again, I will have my email on the last slide as well. So just to go through the contents for today's short CPD. So I'm going to have an introduction to Unitherm, who we are and what we do, bit on TGD Part L and Part F and NZEB, small bit on underfloor heating, leading on to low temperature heat pumps, the integration of these in with Core's insulated foundation, and a bit on compliance and certification. So just a bit about Unitherm then. So we're established in 2004. There's offices nationwide with one in Galway, Dublin and Cork. We provide heating system solutions for residential and commercial projects of all scales throughout the country. All projects are led by a qualified engineer, and we stock a wide range of quality products from a broad range of manufacturers. Let's go into the design here a bit. So I suppose as with new building regs, TGD Part L and Part F 2019, we can easily design compliant, efficient heating systems just off the house plans and by using heat loss calculations with backstop U values. If it's a retrofit job, then we will liaise with BR assessor and organise a site visit. So all our products are tested and certified for use in the Irish market, and all our systems are designed to ensure Part L compliance. System design is complete with integration of mechanical and electrical components. I'm just going to go through a few drawings here now with you. So we design underfloor heating and high efficiency RAD systems to meet heat loss calculations and comply with building regs. So just from the drawings here, with integration of mechanical and electrical components, we have wiring centers, stats, actuators, PLC controllers. We supply first and second fix mechanical and electrical drawings with cable sizes and pipe sizes required for each individual system and heat pump. Thermostat layouts, manifold layouts. There's RAD drawings, RAD layouts. These come with SR50 heat loss calculations, underfloor heat and loop plans, which are all balanced and designed to meet the heat load of the room. We also do ventilation drawings. So we have exploded views of the heat recovery system, and we have multiple of different ventilation systems. And then we do duct layouts as well. So that's just a general example really of some of the drawings we do. Obviously we have bigger commercial jobs as well, and they're very in detail. There's mech and elec, and they're graded over each other with BMS and certain things like that. So we do cater for all sides of projects in both residential and commercial projects. Small bit on supply, and run through this. So I suppose, as I said there, we've one engineer assigned to each project. So every engineer is a balance of customers, and this gives good customer satisfaction and makes sure that the orders get processed on time. As seen in previous slides, we supply full system schematics, and these are sent out with each delivery. The engineer keeps communication between the merchant and the installer. So this just ensures that everything is going to where it's meant to go, and all orders are split into first and second fixes. So this avoids any side complications. There's a next day delivery to location of your choice, whether it be the merchant branch or direct to site. So support, so installer training. So we offer in-house and online installer training. All models are up and running in the showrooms for training and troubleshooting purposes. Installer knows their engineer, so they're dealing with the same person every day or every time they're dealing with them. So along with the full system schematics, we also have setup videos for individual units. There's a technical support helpline, so there's over the phone technical support and on-site support as well there when needed. Commissioning, so we have a pre-commissioning document just to be carried out for the installer. So this is a commissioning checklist so that everything is done as per our schematics. We supply all compliance documentation for all our projects also, and on-site commission of heating systems carried out by one of our commissioning engineers or service engineers. The homeowners can also be present there to run through best practice and optimal operation. So on to TGD Part L. So technical guidance document on the conservation of fuel and energy of dwellings. Just basically going to run through the changes, and where this document came from is basically implemented Articles 7 and 9 from the EPPD, the Energy Performance of Building Directives. So over, I suppose, the last 15 years, we've seen major changes in our building regulations when it comes to energy and ventilation also. So 2005, we took it as a baseline. We've seen the introduction of the energy performance coefficient. This is a non-dimensional figure that expresses the energy efficiency of a building on the basis of energy consumed. And this is for heating, hot water, lighting, ventilation, humidification and cooling as well, but we try to design buildings around without using them here in Ireland. So this is calculated in the DEEP software, and to comply, we must not exceed the maximum permitted energy performance coefficient or the carbon performance coefficient. So as you can see in this table, there's a trend in reduction in primary energy consumption year after year, and this is to do with meeting our renewable energy targets. So we can see the drop down there for the maximum permitted energy performance coefficient down from 0.6 to 0.3, basically halved. Same as the maximum permitted carbon performance coefficient down from 0.69 to 0.35. So also then there was the introduction of the renewable energy ratio of 20%. So basically 20% of the total energy consumed by the building has to be from renewable sources on site or nearby. Here, I suppose, just a graph showing the same again, really. Energy performance of building on a timeline scale, taking 2005 as the baseline again. We've seen a B or a C1. Significant improvement by the time 2007 white paper came out, 40% improvement to B1, and then down to an A3 from 2011. Now we're at an A2 rated building for TGD Part L as of the 1st of November 2020, and all buildings after this have to be NZEB. So from the 31st of January, or so 31st of December, have to be NZEB. So bit on changes to TGD Part F for ventilation. So natural ventilation is out the window. due to the reduction of the air permeability backstop from 7 to 5 meters cubed per hour meter squared, making new dwellings airtight. So ventilation is now controlled mechanically instead of conventional passive vents. Constant operation ensures removal of CO2 and volatile organic compounds. This is for excellent indoor quality. So mechanical ventilations have to be designed, installed, and commissioned by a competent designer and installer as per Part F. So our team of engineers here are all trained and qualified to design, install, and commission these units, and they can give you all sign off on that and certification. Bit on mechanical ventilation. So I suppose types of mechanical ventilation. Centralized extract ventilation. This is basically constant extract from your wet rooms. Now your wet rooms being your kitchen, your utility, and your bathrooms. Demand control ventilation, very similar. You just have extract ducts in your wet rooms again, and then you have passive vents. So there's usually a humidity sensor built in with these, and when that's triggered, whether it's above 60 or 65%, if someone's having a shower or humidity levels are building up in the kitchen, it'll just give it a boost, and that's it. So heat recovery ventilation is our most popular one, and it's basically the most efficient and best practice really for ventilation. So your heat recovery ventilation is extracting warm air from your wet rooms while heating the fresh air from the outside to your supply rooms. So just to go into that a bit further. So with ventilation losses being the biggest contributor to fabric heat loss, by making our dwelling airtight and using HRV, we get a significant improvement on energy performance. The extract and supply ducts feed into a heat exchanger without cross-contamination to transfer heat from the warm air to the cold air at an efficiency of about 90%. So I suppose an example there, if you had warm air at 22 degrees in your kitchen, your bathrooms, your wet rooms, your utility, and cold air outside at 5 degrees, your air supply to your living rooms and bedrooms will be coming in around 18 degrees. So that's taken off wind chill there, like, or any kind of chill you have from dumping out warm air and bringing in cold air and putting more work in your heating system. So there's no compromise on thermal comfort there, as the fresh air is preheated through the heat exchanger before coming into the building envelope. So our blowwork systems as well use humidity sensors to boost the fans when a set point relative humidity level is reached. So like that, you'll have nighttime running levels, daytime, but then there's also a boost level rather than boosting it on a switch. When we'll say we reach 60% relative humidity, the machine will kick on and just bring that down to acceptable levels again of 45 to 55. Bit on NZEB. So Article 9 of the Energy Performance of Building Directive states all member states to ensure that new buildings are nearly zero energy buildings by the end of December 2020. So the NZEB standards applies to all buildings occupied after the 31st of December 2020. A nearly zero energy building, meaning a building that has a very high energy performance. So the nearly zero or very low amount of energy required, I suppose, should be covered to a significant extent by energy from renewable resources. So energy from renewable sources produced on site or nearby. So this is where heat pumps come into play. Heat pumps have become increasingly popular as they're a renewable source of energy. A low temperature heat pump ticks all the boxes when it comes to compliance, ease of installation, consistency of energy production. They have a high coefficient of performance, low running costs, and they're easily maintained. So low temperature air to water heat pumps operate most efficiently at 30 to 35 degrees. And this is why we utilize underfloor heating with them anytime it is possible. Small bit on underfloor heating. Target audience there is all over this place. So like we have homeowners, we have this, we have that. We'll just get into it. So bit on underfloor heating. So underfloor heating is defined as that which warms the floor structure, including the floor space, in order to heat the room above. So here you can see a cutout of a standard underfloor heating system. And these are the normal methods, I suppose. The floor insulation is bedded on top of your concrete slab. Then you have a vapor barrier placed over this. Pipe tracking or rapid railing system is clipped down to accommodate an array of pipes, usually at 150 to 200 mil centers. Then you have your sand and cement or liquid screed poured on top of this to create your floor structure and your thermal mass for heating. suppose why go with underfloor heating then? So underfloor heating is probably the most efficient type of emitter to heat your home. As the floor is your emitter instead of traditional system emitters such as radiators, you now have a much larger area. So like if you have a bigger area, instead of a small radiator with a high flow temperature, you can go with a bigger area and a lower flow temperature. So obviously the lower the flow temperature, then the higher the efficiency of the heat pump and the lower the running costs. Also, I suppose the thicker the screed for the underfloor, the more thermal mass it will have and the more radiation it will produce. So high radiation outputs there due to thermal mass being heated. So a bit here taken from the underfloor heating design and installation guide. Now this is based on a 75mm standard cement screed, which is pretty normal for ground floor screed installation. So the method of heat transfer from the heated floor surface is circa 55% by radiation, plus 45% by convection, plus minus 5%. Depending on surface to air temperature differential, because the majority of the heat is radiant, it creates occupancy thermal comfort at lower air temperatures than what would be expected from radiators, convectors, and warm air systems. So they were just saying by the thermal mass radiating, we can expect occupancy thermal comfort at lower air temperatures. So I just wanted to take note of that there, and we'll get on with this then and we'll see. So low temperature heat pumps. So there's a mix of low temperature air to water heat pumps that we do, the LG, the Hitachi, and the Daikin. Today we're going to talk to you about a revolutionary new LG Therma V. This one SCAI best renewable product of the year there when we brought it in 2019. So it's the world's first R32 monoblock. Now, I'm sure you all hear of R32 lately. And what is it? It's basically the 5th generation refrigerant, and this is replacing R410A. So R410A has been phased out by 2025, and this is mainly due to its high global warming potential of about, I think, 2080 or 2090, 2088, I think. Whereas the R32 is significantly lower global warming potential, about 66% lower at 670. So the LG Therma V is an ideal solution for both new builds and also retrofit projects due to its wide operation range from 25 degrees to 65 degrees Celsius. And these ranges can be achieved, these flow temperatures can be achieved without the use of a backup heater. Now that's basically unheard of, and I'll talk to you about that again. But like a normal standard air to water heat pump will heat up to 52 to 55 degrees, and then it'll bring in the backup heater to heat it up to 60 for doing disinfection and stuff like that. So the LG Therma V can heat up to 65 degrees without a backup heater. Excellent performance at low temperatures. So down to 100% performance down to -7. Now for NZEB buildings, the weathercom floor temperature is typically 32 to 38 degrees. And running at a lower temperature gives minimal input with highest COP value, so highest coefficient of performance. New type scroll compressor varies running frequency with precise control. The lower the required flow temperature, the lower the frequency, and the lower the bills. So the flash gas injection. So this is where I come back to the 65 degrees there. So normal thermodynamic cycle, your compressor can only get so much heat out before it overheats. So with the LG Therma V and the flash gas injection, when it's compressing, it's halfway up its thermodynamic cycle, it gives it a wet vapor injection, and this cools the compressor so it can further compress and get higher pressure and higher temperatures out of the thermodynamic cycle. Just a quick look at some capacity tables. So as I mentioned, you have 100% performance down to -7. So -7 degrees here on the left is our outdoor temperature. TC up here is total capacity. Now that's total capacity without a backup heater, whereas majority of heat pumps will show total capacity, but that will be including a backup heater. So with 7 degrees down to -7. Our heating test standard is EN 14825, and that's taken air at 7 and water 35. So air at 7, water 35, we have a COP of 4.5. There's a low degradation of the COP then, like, so we're still getting COP of 3 even at -7. And we'll be running these on a lower weather compensation curve between 30 and 35 degrees. So between, even at -7, you have full capacity, and between 3.15 and 2.96 is your COP. Average weather in Ireland is 10 degrees on average, supposedly all year round. but obviously we will get the minuses at winter time. So even at 10 degrees on average, if you take an average of 4.78, the seasonal COP for this unit for the 5, 7 and 9 kilowatt is 4.45. So even all the way up to 60 degrees leaving water temperature there. Oh, excuse me, sorry there. All the way up to 60 degrees leaving water temperature, you're still getting 100% performance. So you're still getting the 7 kilowatts out of it. So I suppose this is what we're getting to here. The integration of the LG Therma V and underfloor heating with Core's insulated foundation. So as I said there, complete peace of mind on these cold winter days with the LG Therma V. As you were guaranteed 100% performance down to -7 degrees. With Core's insulated foundation system, as Andrew said there, exterior wall to floor thermal bridging is basically eliminated. This gives your underfloor heating great relief at external walls and takes pressure off the system in those colder north-facing rooms as well. So, as with floors and external walls are big contributors to heat loss of a building, we've considerably lowered a lower heat load to consider, which lowers the required heating capacity of the heat pump and therefore brings down capital costs and running costs. So just going to look through the build-up of Core's insulated concrete foundation here and how we utilize it with underfloor heating. So as Andrew said there, maybe 200 mil of T3 compacted gravel or compacted stone. This is all leveled out. Then you have your core insulation. We'll just take it as 150 mil core, 150 mil insulation, vapor barrier, rapid rail track, and then this is to house your underfloor heating pipe, just so you can get the proper centers throughout the house and even heat distribution. Then there's clips for the railing, and then we have a 16 mil PEX alu PEX, or there's a PEX alu pert as well, which is easier to work with. And these are all clipped down as well. So then we have 150 mil reinforced concrete, so the pipes are in that. So with the, obviously we've twice the amount of heated screed or heated slab as we would normally have there now, compared to a 75 mil screed. So I'll just talk to you a bit further about that. So as mentioned previously, for 75 mil screed, the method of heat transfer from the heated floor is about 55% radiation and the other 45 convection. So with 150 mil slab instead of a 75 mil slab, we've now doubled the thermal mass in the floor, therefore significantly increasing the longevity of radiation from the floor. Because the majority of the heat is now predominantly radiant, it creates occupancy thermal comfort at even lower air temperatures. So with our high thermal mass, we can now utilize the thermal mass and run our heat pump at night time with a low temperature weather compensation curve. This is to charge the floor so it can radiate heat throughout the day. By running our heat pump at a night rate meter and high thermal mass in the floor, we can take full advantage of night rate tariffs, the same as we would with the old conventional storage heaters. So we have graphs here. I was trying to put them in there yesterday, but I was kind of got a bit caught up. Should have put them in earlier, but one of the lads here in the office, he has a 75 mil screed and he charges his floor at night. Now that only drops off in the evening around, probably gets from 9 o'clock in the morning to, I think it's 7 o'clock in the evening at 21 degrees and drops down to 18. So he needs to kick it on again. But with increasing your thermal mass, basically we can just let that run it all night, and then it'll radiate heat throughout the day, but it'll radiate it slowly. You know, it's more control over the heat when it's charging a bigger slab, and it'll radiate it more evenly throughout the day. So that's where we're going with this, and that's ideal way, and that's what I'll be doing in my own build. So just on to compliance and certification then. So all our products are CE marked and they're all tested to EN standards. We liaise with, we liaise with BR assessors for homeowners, and then we supply them with everything they need for sign off, from deep 4.2 inputs, eco design data to back it up, designer installer sign off forms, and all technical specifications. And so we supply ancillary certs for design and completion, and inspection certs as well on request. We're also members of the Heat Pump Association of Ireland, so we liaise in conjunction with SAI on compliance. Just going to go through that a bit further there. So designer installer sign off form. So this is done by us in-house here. It states the type of heat pump system installed in the project and verifies running parameters. The designer installer sign-off form is needed by the BR assessor, as these parameters are entered into DEEP 4.2 to quantify the heating and hot water performance of the building. So along with the designer installer sign-off, I suppose the second part of it is the heat and design tab, and this is all completed along with SR50 heat loss calculations. So we do this in-house with our system design, and this is all done immediately just to give you a correct calculation and outputs of your heating system. So this gives you a total heat loss for the building, total heat output of the emitters installed, and a design heat loss indicator. So like we just see there, a total heat loss for this building of 9 kilowatts. The total heat output of emitters is 15 kilowatts. There's an 11 kilowatt unit running in that. And the heat loss indicator is 1.49. Bit more in compliance there. As I said, we do engage with the BR assessors. We have DEEP 4.2 input documents, as with the old DEEP 3, you could share an XML. The BR assessors would send that to us. We'd fill it out, send them back a heat pump tool, designer installer sign off. But now it's just everything's online, and so you can't share it. So what we do is we just make our own sheets that they can basically know where we give them all the data. We'll show them where to put all the data in, and they can correspond with that and match it up just to make sure it's all correct. So we give them the inputs. Designer installer sign off is from a heating system supplier such as ourselves, and the eco design data is from the manufacturer. So a bit on, I suppose, EN 14825. This is the heating system test data. Heat pumps are tested at low and high temperatures at full and partial loads, and this is just to get an average loading of heat pumps, just to see how it'll operate and see how efficient it'll come in on loading the house. So these are all backed up, as I said, with eco design data. So then hot water efficiency data, same thing again. Hot water cylinders are all tested with associated heat pumps to EN 16147, standard for heating, providing hot water efficiency. These will all provide your hot water efficiency, declared load profile, standby heat loss, reference temperatures, and all that. So distribution losses and storage losses, again, same thing, just going through that. So design flow, these are all taken from your designer installer sign off. These are your your eco design data to back it up. Same here again. And as I said, we do ancillary certs for design, inspection, and completion. These are all available. Commissioning cert then, these are supplied from the manufacturer. So we do this and we supply it with the serial numbers of the unit, type of system, control, along with commissioning checklist to make sure everything is done on site. As for, if it's not, we'll have to come back and make sure it's done next time. So there's an extended 5-year warranty in place that we go through. So does any issues arise, we have contact Unitherm service department. There's a sticker on your unit and it'll be dealt with promptly. So thanks everybody for your time, and I'll give you my email address there again, just if you have any queries or you want to send me on any queries on that, just to contact me. So thanks a million for that. I'm going to hand you over now to Lisa, and she's going to go through our Q&As.
Thanks very much, Liam. So first off, I just want to let everybody know that we have recorded this webinar, and the email will be sent out to you later if you did miss the start of it. It has also been live streamed on Facebook, and it will be kept as a video there. So if you want to search, it's at Core Ireland. So now we will start with the questions. So first off, we have for yourself, Andrew, does the cost estimate include consultant costs like structural engineer, etc.? For the, I'm assuming for the core insulation.
I'd imagine for the ventilation system. Yeah. So there is a structural engineer design required for a foundation system. A structural engineer will take into account the compressive strength of the soil, obviously the line loads of the building and the structure that's going to go on top. So there needs to be a structural engineer involved in it. If somebody has a structural engineer already on their project, we can give them the information, the structural design guide, the declaration of performance and material, give them all that information that they need to design it, along with examples and that kind of stuff. So if certainly if we're on to, say, developments of houses, they have a design team, structural engineer design team on hand anyway, so there's no additional cost. if you have a structural engineer involved and it's a one-off house build, maybe the engineer isn't overly familiar, we can recommend a structural engineer, and there would be a small cost associated with that. But again, we can give you ideas on costs in it. But ideally, what we'd like to do is help, I suppose, upskill the structural engineers there. But the cost estimates that I had up there, even bearing in mind any of the design costs, people were still saving money on their projects, which is great to see.
Great, thanks, Andrew. The next one, if you have a sloping site with, say, 500 mil cut on one end and about 700 mil stone fill at the other end, is it possible to use Core's insulated foundation system?
It certainly is. If you want to email me, I can send you on a typical detail that I put together actually a few weeks ago for that. So you can do the T2 stone build up to around 750 millimeters, and we have supplied foundation systems to sloping sites. If it goes beyond that depth, even if it was a very big site with a heavier slope on it, you can go beyond that with a heavier stone, a T1, even possibly a T0 below that. So there's no issues going up to that depth of stone and even beyond that. So that's no problem.
Now over to yourself, Liam. Do you offer a geothermal heat pump system?
Hi, Lisa. Sorry there. So Unitherm don't supply geothermal heat pump systems. We deal predominantly in air to water. We do exhaust air heat pumps, and we do mechanical ventilation heat recovery. So the answer is no. We don't supply geothermal heat pumps.
Right, and the next one for yourself, Liam, the mechanical heat recovery ventilation, what qualifications or certifications does the designer and installer have to have?
So there is BCAR certification there for the designer installer. So we had to go to training down in Escorty there. So there was 5 of us went down and got trained up in it. I can, if you can get me that, if I get the email address there of that, I can send on the exact ones. I should have it there now, but I don't.
It's just down as an anonymous, so if that person would like to email Liam, it's Liam@Unitherm HS.
Yes, please send me an email at Liam@Unitherm HS, and I'll get back to you with that.
Okay, the next one as well. Has underfloor heating systems changed much in terms of lack of control, say on a sunny winter's day to avoid overheating when slab keeps emitting radiant heat despite increase in solar gain? Can this be offset by ventilation systems?
Yeah, so I suppose with this one, obviously it will depend completely on house design, the amount of solar gain you have, the amount of south facing windows. But with 150 mil slab, your radiant heating, it is a lot slower release than we'll say your standard 75 mil slab. And as I said, we will be charging with lower temperatures as well, so it will come off a lot slower. So it can be offset by the ventilation systems with a summer bypass. But like that again, house design should be thought of there, I suppose, to be designed around overheating as well. I know sometimes a lot of people go for excessive solar glazing, and this, like, the house will overheat if there is underfloor in it or not.
And another one for yourself, Liam. What are the pros and cons of monoblock versus a split heat pump?
So with the monoblock there, as I said, with the LG Therma V monoblock, I suppose efficiency is a big thing on this one. You have a wide operation range between 25 and 65, and when operating this at 30 to 35 degrees, you're basically running it at best efficiency point and highest COP. A split system utilizes refrigerant piping. The big thing for the monoblocks is retrofit, but the split system utilizes refrigerant piping and a long run refrigerant piping. Sometimes this can be problematic with installation. So you're an LG monoblock or a monoblock in general, you would keep them close to the house. They're great for retrofit jobs. And as I said, they're best efficiency design there at 35 degrees.
Okay, and this one's for you, Andrew. What is the minimum depth of a slab for underfloor heating? The core insulated foundation system?
90 odd % of the time, the slab would be 150 millimeters thick with an insulated foundation system. Over the years, we have seen some foundation systems with 100 and 125 mil of concrete as well, depending on the build method and the engineer who's designing it. The 150 mil slab, there's a nice balance of thermal mass and the reinforcement that would go into it as well. So normally we'd see 150 millimeters.
Thanks, Andrew. Back to you, Liam. If you were heating at night, isn't the air temperature lower, so the A2W unit has to work harder?
Yes, this is correct. So we'd say with winter time, there is an offset of it. So there's calculations done there. So obviously with winter time, your air temperatures are a lot lower, but generally from spring, we'd say March till November, your air temperatures at night time are generally around between 7 to 10 degrees. So anything above 7 degrees or even down to 5, we're still getting a COP there of 4.5. So it does make a big difference. Like, you're still getting 4 units of heat for every unit of electricity. So it doesn't really offset it till you go down, as I went through the term or the tables there. It doesn't really offset it too much until you go down to below 2 degrees at nighttime. And if this is the case, you can have it running during the day. But like, if to take it on average throughout the year, you know, like you would anyways with your heating system, it does work out a lot cheaper running it at nighttime and charging the slab that way. Like, there's nighttime rates there now with Energy of 7 cents a kilowatt at nighttime. So it is considerably cheaper.
Great, thanks, Liam. Back to you, Andrew, just to follow up from the last question. What is the minimum depth of the core raft to underfloor heating with an ICF wall to avoid damage of underfloor heating pipework from ICF temporary bracing?
So just to answer that one, I suppose normally we're seeing 150 mil thickness of slab, compliance with the CERT. That's what we have in that as well. So the underfloor heating can be in 2 places within the slab. So as Liam would have shown and I would have shown in the presentation there, with the underfloor heating pipes on the last layer of insulation, so it's well below into the slab. So if you're fixing a brace for your ICF, you're going to be shooting, I suppose, a fixing into the ground floor. It's going to be well below that. Sometimes as well in a slab, people will tie the underfloor heating pipes possibly under the reinforcement mesh, which is about 75 mil up the slab. So you still have a 75 mil cover above the steel. So you're going to be well covered in terms of protecting that pipework there.
Thanks, Andrew. Liam, which would you pick, Hitachi or Daikin heat pumps?
I suppose. Yeah, well, I suppose like it's up to yourself really. Like, you know, it's what you want. Both units are R32. They're both splits. They both have integrated and separate hydrobox options. They both have monoblock options. It's just completely up to yourself. Whether it's price, do your research, go for what tickles your fancy, I suppose. I wouldn't be biased in that sort of thing.
Okay, and mechanical heat recovery, can it be used for cooker extraction units? So
ideally, no. Now at the same time, like when you're in that case, myself and building there, and I have a vaulted ceiling, I'll be going with a downdraft, the downdraft hob basically. And now your heat recovery is just for your indoor air quality, but at the same time, you don't want to be pulling grease and steam into it if there's no need for it, like, you know. So generally, no, you wouldn't put an extract for a heat recovery unit over a kitchen hob. You'd have it at the opposite side of the kitchen. So no.
And Andrew, have you previously integrated the raft with piles?
Yes, we have indeed. If a site is particularly poor, we've actually supplied the foundation system to a couple of sites where they were looking at piling. The ground was poor, and simply by increasing the depth of stone under the system, they actually countered that issue. They were able to establish a known compressive strength within the stone to allow the system to work, and actually negated the need for piles. But if it was really, really bad and you'd no choice but to use piles, through a series of ground beams, the foundation system can be made working with piles. There's a couple of different ways of doing it, where again, trying to maintain that thermal envelope, reducing that thermal bridging down as best as possible. If you want a detail on that, Brian, just pop me an email and I'll happily send that on to you.
Great, thanks, Andrew. And another one, do Core have an installation team for the slab, or might an ICF installer be contracted to do it? And do they need to be certified with Core?
So we would have, obviously at this stage, we've a lot of people who would have experience with the foundation system, and we have, similarly as we do with the engineers, we have a register of installers. If somebody wants the name of somebody, we can give them that. But if you have a team who's going to be doing your groundworks, or your building, or in this case, an ICF installer, and they want to take on the installation of a foundation system, all they need to do is get in touch with me. I'll organize the training with them. From what they're doing, it's a very, very easy thing for them to take on this end of it as well. We've an online training course. I'll organize all that with them. So if you have a builder, as in this case, you have an ICF crew, if you have a groundworks crew, we can update these people, give them the training that they need to take on the installation. There's no big issues there.
Thanks, Andrew. And Colleen, the webinar has been recorded and it will be still on Facebook for the foreseeable, and we will send you a link to the recording so that you have it forever. And just over to you again, Liam, what range of HRV systems do Unitherm have?
So we have a couple of options there. We have the Frankischer Profier 400 and the Profier 200. This is a German brand. They have their own distribution system. They're anti-allergy, low K factor, so they are a great unit. The other one is Blauberg. So we have a Blauberg SB 160 meters cube per hour, SB 350 is 350 meters cube per hour, and SB 550, which is 550 meters cube per hour. So the 350 there will generally do, as again, that's German brand again, they're a great unit. They have, the 350 will generally do a house from 180 to 260 meters squared. So it's 350 meters cube per hour ventilation. And then for over that, from the 260 to the 400 meters squared house, we have the 550. And obviously the 160 then will do houses under 150 meters squared. So yeah, so all the Blaubergs come with a built-in humidity sensor. This comes as standard, and it's a great way. Like, a lot of systems there have boost switches, like, but I find the Blauberg with the humidity sensor is a great way of just boosting it. You can set your relative humidity set point so that when it senses it in the duct, it'll go, right, listen, there's a bit of processes going on here. We need to get rid of that steam. Now, what I find as well, just when I'm on the topic, thanks, Patrick, for your question, but I see some things coming up there in Facebook about people are trying to dry out their houses for the first time, and they're using their heat recovery ventilation. Ideally, heat recovery ventilation should only be turned on when the house has dried and settled. You know, so it shouldn't be used when the house is 90% humidity, like, and they're just dry in the house and they're drawing any amount of condensation through the filters, and they might damage the unit that way. So if anyone's listening, I just advise against that, and just wait till your house is actually dried out with your windows open and your heat pump on and your underfloor on until you do run the heat recovery. So heat recovery should just be put on when you're actually living in the house. Sorry for a rant there.
Laura, yes, there will be a recording and an email will be sent to everybody with the link. And if anybody wants a CPD certificate of attendance, please email us marketing@coursesystem.com. And another one for you now, Liam. If you want to install underfloor heating in a liquid screed over the concrete screed, would you install in a screed directly over the slab, or install a thin insulation between if the plumbers were not appointed at a foundation stage?
Well, I suppose you wouldn't go like that. It kind of defeat the purpose there, I suppose. Like, if you wanted to go with the core insulated foundation and you wanted to go with underfloor heating, you would have to have a plumber sorted, or you would have to have it done beforehand. Generally, you're on about two ways of doing it. I myself wouldn't personally, or wouldn't advise on tying the pipes to the steel. I would clip them onto the insulation, and, like, rather than put them in the middle of it, I'd put them at the bottom, because heat's going to travel to the place of least resistance. So if you have it, put a screed on top of the slab, it's going to go down as well as it's going to go up. Now, it'll just mean you have an even thicker slab. Instead of 150, you have 150 plus 75, so you have 225 mil of slabbed in, and that's a massive thermal mass. So it just, your heat up time would take a lot longer, and if you want to go putting a thin insulation in between, you are still going to get heat loss through it. But ideally, I would just say no. Install your underfloor heating pipes in your slab. This is why you're doing this. Did you know you are saving on thermal bridging, but also, if you're going down that road, you want to be installing it in the one slab. You don't want to be pouring two slabs and incurring extra costs.
And what are the warranties on the heat pumps, Liam?
So warranties on the heat pumps. So we give extended warranties on all our heat pumps. This comes down to a yearly service as well. I suppose it's maintenance really. Standard manufacturer's warranty, I think, on all of them is 3 years. And then we extend that to 5 years with a yearly service. So yeah.
Great. And is there much difference in SCOP and the COP between split and mono heat pumps?
So there is actually, like, I know, like with mono heat pumps, like we had, like there's the Hitachi monoblock, there's the Daikin monoblock, but the LG monoblock is way ahead when it comes to seasonal COP. There's a seasonal COP of 4.45. That's very high. I guess even a seasonal COP on the Hitachi and the Daikin split is lower than this. I should have figures handy there. If you want to send me an email to Liam@Unitherm HS, I can give you the exact figures, the seasonal COPs for all our units in-house. Hitachi, Daikin, LG, the comfort zone exhaust there. I have them all there readily available. But the difference in the COP, the LG monoblock, the LG Therma V monoblock has higher seasonal COPs than any other of its monoblock counterparts. As I said, it's the world's first R32 monoblock, and it utilizes that wet vapor injection, which gives it higher enthalpy values on the thermodynamic cycle. But the COPs, there's a lower degradation COP on the Therma V. Even down to -7 there, we're still getting 3.13 of a COP, like, and that's very good. Like, so the seasonal COP is 4.45. I think on the split units, it's in around 4.1, 4.2. So yeah, that's the difference. And if you want to send me an email, I'll clarify that with documentation. So once again, liam@unithermhs.ie.
Liam, what type of cylinder is used with the LG heat pump for hot water?
So the LG heat pump is tested with the Kingspan heat pump cylinder. So we got our own cylinder tested we liaised with Kingspan and LG and got our own cylinder tested to EN 16147. It comes in 210 liters or 300 liter cylinder. And like, this is a pre-plumbed cylinder, and there's a low standing heat loss. So yeah.
And Liam, a well-insulated house should not have its heating running from April to October. How does this make the additional cost of nighttime meter cost effective?
Sorry, where's that one? A traditional?
It's in the questions and answers.
Yeah, sorry. A well-insulated house should not have its heat running from April to October. Well, you're still using domestic hot water, like, so you still have it for that. And you're only, like, you're not just going charging the slab to a certain temperature, like, you're charging the slab to your required thermal comfort. So your set point stats are set on 21 degrees, maybe 22 for some people, 18 in the bedrooms. So like, if you're charging the slab, you're getting up to that temperature. That slab then, like, it's going to get to that. It's not going to really overheat. You might set it to 20, it'll get to 21. And with the thickness of the slab, it heats slowly throughout the day, like. You know, and even with the 75 mil screed, like, there's no big overheating, but it just drops off a lot quicker with the 75 mil screed. You might get to, like, as I said, 7 o'clock in the evening, whereas the 150 mil screed, you're guaranteed to be getting to 10 or 11 o'clock at night until you want to turn it on again. And it wouldn't take that much to top it up either, you know. So yeah, like, a well-insulated house should not have its heating running. It depends on the solar glaze, and it depends on a lot of things. But it depends on the set point thermostats in the walls. It's calling. North-facing rooms might want a bit of heat, and south-facing rooms won't. And that's why you have it zoned room by room.
Thanks, Liam. And the final one now. Is there any special requirements on the paint finish of the heat pump in coastal locations?
So all our heat pumps come with, I suppose, the LG Therma V there. It's blackfin technology, what it was. So like, there is standard model heat pumps, but then there's also, we'll say, I know some people think it's farce, but like, the LG there and our other units, the condenser is coated. So it's coated like a plastic filming, and it's protected from corrosion and rust. We also have salt air letters for these. And there's also a special painting for the outdoor housing of the unit. It's called Blygold, and if that's there, if required as well. Like, but like, we have units out in the Aran Islands the last 15 years, and there's no issues with them. We have them down in Cove in County Cork, and like, you couldn't get any more coastal or southern than that, or salty air than that. So yeah, there's not much issues with them, you know. If needs be, the bly gold is there. You can basically coat your whole unit with this gold, but there's no need for it.
Okay, thanks. And if anybody has any questions for Andrew, you can catch him at andrewbutler@coresystem.com, and Liam is at liam@unithermhs.ie. I'd like to thank you all for coming today and attending our online webinar. And again, if you would like a CPD certificate of attendance, you can email us marketing@coresystem.com. Thank you guys for attending and have a wonderful day.